Holy shit, exoplanets. You're diving into some seriously mind-bending stuff.
You're telling me.
I mean, planets outside our solar system.
Entire worlds.
Entire worlds just hanging out in the vast cosmic abyss. That's some next-level shit right there. You've got a stack of Wikipedia articles on this.
Which is cool and all.
But let's cut the crap and get to the juicy bits. No one wants to wade through a goddamn encyclopedia.
We're talking about over 5,787 confirmed exoplanets.
Spread across
more than 4,320 planetary systems. And hold on to your butts because 969 of those systems have more than one planet.
Hold up.
That's right.
How the hell do we even find these things? They're light years away.
It's a cosmic game of hide and seek.
We can't just whip out a telescope and be like, hey, there's a planet.
But instead of looking for your annoying little brother, we're searching for subtle clues that betray a planet's presence.
Okay.
We can't usually see these planets directly, but we can see how they affect their host stars.
So it's like cosmic detective work.
Exactly. And we've got a whole arsenal of techniques. One of the coolest is the transit method.
Beat me with it.
Imagine a tiny fly buzzing across a giant spotlight. You might not see the fly itself.
Okay.
But you notice a slight dip in the light's intensity.
Okay, I'm following. So how does that relate to planets?
When a planet passes in front of its star, from our perspective, it blocks a teeny tiny fraction of the star's light. We can measure that dip and bam, evidence of an exoplanet.
So we're basically looking for shadows. That's some seriously subtle shit.
It is. But our instruments are incredibly precise. We can detect dips in brightness that are mind-bogglingly small. It's a testament to human ingenuity, really.
That's pretty badass.
Yeah.
So are most exoplanets like the ones in our solar system, or are we talking about some seriously freaky shit?
Oh, we're definitely talking about some freaky shit. We found hot Jupiters.
Hot Jupiters?
These massive gas giants that orbit ridiculously close to their stars, like so close they're practically kissing. The temperatures on these planets are insane.
Sounds cozy.
We've also got rogue planets.
Rogue planets.
Planets that don't orbit any star at all. They just wander through the galaxy like cosmic nomads.
Okay.
No sun to warm them up, just eternal darkness and solitude. Spooky as hell, right?
Rogue planets. Those are fucking terrifying. Imagine a planet just barreling through space with no sun to warm it up.
Exactly. And then there are planets with rings that make Saturn look like an amateur.
What?
We're talking rings so vast they'd stretch across a significant chunk of our solar system.
And we thought Saturn was the ring king. This shit's wilder than any sci-fi movie. Are you telling me some of these planets could have volcanoes too?
You bet. We've even got evidence suggesting that volcanic activity might be happening on some of these exoplanets. Imagine the kind of eruptions we'd see on a planet with way more gravity than Earth.
Dude, I don't even want to think about the size of the space rocks they'd be chucking out there.
Yeah.
But wait, before we go full-blown Armageddon, there's something I don't get. You know how we were looking at that Wikipedia article earlier? There's this thing called the radius gap.
Right.
Apparently planets between 1.5 and 2 times the size of Earth are super rare. It's like they just vanish. Where did all the medium-sized planets go?
That's a great question. The radius gap is a real head-scratcher for scientists.
Okay.
It's like finding a missing piece in a cosmic jigsaw puzzle. We've got some theories, but no definitive answer yet. One possibility is that planets in that size range are inherently unstable.
Okay.
They either lose their atmosphere and shrink, or gobble up more material and become gas giants.
So they either get stripped down to their skivvies or bulk up like cosmic bodybuilders. I like it. It's like a cosmic gym out there, survival of the fittest and all that jazz. But you mentioned habitable planets earlier.
Yeah.
Are we talking about finding another Earth? Another place where we could, pack up and move if this whole climate change thing gets out of hand?
The holy grail of exoplanet research is finding a truly habitable world. And there are some tantalizing candidates. Planets that sit right in that sweet spot where conditions might be just right for liquid water. You know, the essential ingredient for life as we know it.
Spill the beans. Which planets are we talking about?
Well, there are a couple of rock stars in the exoplanet world.
Okay.
Kepler 186 and Proxima Centauri b. Both are relatively close to Earth in cosmic terms.
Okay.
And they orbit within their star's habitable zones.
Sounds promising. Are we packing our bags yet?
Hold your horses.
Right.
Remember, habitable zone doesn't mean Earth 2.0. Just because liquid water might exist on the surface doesn't mean it's a tropical paradise.
Bummer. What are they like then? Cold and desolate.
Think more along the lines of potentially frigid and with conditions we can only speculate about.
Right.
We don't even know for sure if they have atmospheres or what those atmospheres might be made of.
Okay, let's say the Dio have atmospheres. What else could screw things up?
What we consider habitable is more complex than just liquid water. We need to think about things like a planet's magnetic field, which acts as a shield against harmful radiation from its star. And then there's plate tectonics, the movement of those massive plates on a planet's surface. They play a crucial role in regulating the climate.
Okay, so maybe not beach weather. But could there be some kind of freaky alien life out there?
The possibility of life existing in those harsh conditions is mind-blowing, right?
Yeah.
Some scientists even think there might be life in subsurface oceans, similar to what we suspect might exist on Jupiter's moon Europa.
Hold on, subsurface oceans. You're telling me there could be alien squid swimming around under the ice on some faraway moon?
Hey, it's not entirely out of the realm of possibility. Remember, we're talking about the universe here. The possibilities are endless. What we think of as habitable might be totally different for alien life forms.
This is getting deep, man. So you're saying we need to broaden our definition of what a habitable planet looks like?
Exactly. It's not just about finding another Earth. There could be all sorts of weird and wonderful worlds out there that support life in ways we can't even imagine.
Dude, my mind is officially blown.
And we're just getting started.
All right, so now that we've covered the basics,
Right.
let's dive into some of the really bizarre stuff. What about those tidally locked planets mentioned in those Wikipedia articles? What the hell does that mean?
Tidally locked planets are like those creepy dolls with eyes that always seem to be following you.
Okay.
One side of the planet always faces its star, just like the moon always shows the same face to Earth.
Okay, so one side is in perpetual daylight, and the other is shrouded in eternal darkness. That's some Edgar Allan Poe shit right there.
Exactly. And think about the weather patterns. You'd have extreme temperature differences between the two hemispheres. The day side would be scorching hot, while the night side would be freezing cold.
Imagine the wind on a planet like that. It'd be like a never-ending hurricane.
And the visuals. Some scientists believe that tidally locked planets might actually resemble eyeballs, with the star's heat creating a giant staring pupil on the day side.
Dude, that's both awesome and creepy as hell.
But here's where it gets even more interesting. Recent research suggests that clouds on these tidally locked planets might actually make them more habitable than initially thought.
Wait, what? How the hell does that work?
Think about it. Clouds reflect sunlight, right? So if a tidally locked planet has thick cloud cover on the day side, it could actually help to moderate the temperature and prevent the surface from becoming too hot.
So those creepy eyeball planets might actually be comfy little havens for alien life. Man, the universe is full of surprises.
It is indeed. And that's just one example of how our understanding of habitability is constantly evolving.
Right, so if it's not all about liquid water and Goldilocks zones, what else should we be looking for when we're hunting for habitable exoplanets?
We need to consider things like the planet's magnetic field, which shields it from harmful radiation from its star. A strong magnetic field is essential for life as we know it.
So like a cosmic force field protecting those little alien dudes from getting fried? I dig it.
Exactly. And then there's plate tectonics. The movement of these giant plates on a planet's surface plays a crucial role in regulating the climate.
Okay.
Without plate tectonics, a planet could experience extreme temperature swings that would make it very difficult for life to survive.
Plate tectonics, huh? So we're talking about a planet that's literally alive and shifting beneath our feet. Sounds kind of dangerous, but also pretty damn cool.
It is cool. Plate tectonics is responsible for creating mountains, volcanoes, and even entire continents. It's a dynamic process that helps to keep a planet's climate in balance.
So we're not just looking for planets that look like Earth.
Right.
We're looking for planets that ACT like Earth, too. Planets with a heartbeat, you could say.
That's a great way to put it.
This is mind-blowing stuff. I'm starting to feel really small and insignificant in the grand scheme of things.
Don't feel small. The fact that we can even contemplate these questions is a testament to the power of human curiosity and our ability to explore the universe around us.
You're right. It's fucking amazing.
It is. And the more we learn about exoplanets, the more we realize how much we still don't know. There's so much more to discover.
So what's the craziest, most out there possibility when it comes to exoplanets? What keeps you up at night?
Well, we've been focusing on finding life as we know it. But what if there are forms of life out there that are completely different from anything we've ever imagined?
Life that doesn't need water. Life that breathes methane or eats rocks. Now you're really messing with my head.
Exactly. We need to be open to the possibility that life might exist in ways that we can't even comprehend. It might be based on entirely different chemical elements or operate under completely different physical laws.
So instead of searching for Earth-like planets, we should be looking for what? Life-supporting planets. Is that even a thing?
It is now. We need to expand our definition of what a habitable planet might look like. It's not just about finding another Earth. It's about finding any planet that has the potential to support life, no matter how strange or unfamiliar it might seem.
Man, the universe is a wild and crazy place, and we're just beginning to scratch the surface of what's out there.
Absolutely.
All right, I think that's enough for now. We've covered a lot of ground already, and I need a beer.
Yeah.
Stay tuned for part 2, folks, where we'll dive even deeper into the weird and wonderful world of exoplanets.
Welcome back to our deep dive into the mind-blowing world of exoplanets.
That's right, folks. We're back for more cosmic craziness.
In part 1.
In part 1, we talked about how we find these alien worlds.
Right.
And some of the crazy types of planets out there.
But that was just the tip of the iceberg.
But that was just the tip of the iceberg. Now we're going to dive even deeper.
Exactly.
And explore some of the most extreme and bizarre exoplanets we've discovered.
Planets that push the boundaries of what we thought was possible.
They make our solar system look like a cosmic retirement home.
Seriously.
Exactly.
Right.
So buckle up, because we're about to take a wild ride through the weirdest corners of the universe.
Okay.
Hit it. What you got for us?
Let's start with a real gem.
Literally.
Literally. Have you ever heard of 55 Cancri?
Can't say I have.
It's
Is that one of those tidally locked eyeball planets we were talking about before?
not quite. 55 Cancri E is a super Earth,
Okay.
about twice the size of our planet.
Okay.
But here's the kicker. It's largely made of pure crystallized carbon.
Hold the phone. You're telling me there's a planet out there that's basically a giant diamond.
Essentially, yes. The intense pressure and heat deep inside the planet have forced the carbon atoms to bond together in a super strong crystalline structure. Imagine the bling on that bad boy.
We're talking about a rock that would make the Hope Diamond look like a speck of dust. Holy shit.
It's estimated to be worth something like $26.9 million. That's a 26 with 30 zeros after it.
I don't even know what that number means.
It's a lot.
But it sounds like a shit ton of cash. Someone get Elon Musk on the phone. We've got a planet to mine.
Hold your horses there.
What now?
55 Cancri E is about 40 light years away.
Okay.
And it orbits its star incredibly close.
Okay.
It's scorching hot, with surface temperatures reaching thousands of degrees.
Damn, there's always a catch, isn't there?
All right.
All right, what else you got? Hit me with another one.
How about a planet that rains iron?
It rains iron.
WSP-76b
WASP 76b.
is a gas giant located about 640 light years away.
Okay.
It's tidally locked to its star, just like those eyeball planets we discussed earlier.
Right?
And get this, the dayside temperatures are so extreme that they vaporize iron.
Vaporize iron. We're talking about turning solid metal into gas.
That's right.
How hot does it get over there?
Over 2,400 degrees Celsius, or about 4,350 degrees Fahrenheit. Hot enough to melt almost anything.
That's insane. So what happens to all that vaporized iron? Does it just float around like a metallic cloud?
Not exactly. Strong winds carry the iron vapor to the night side of the planet, where it cools and condenses, forming clouds of molten iron droplets.
And then
Right?
it rains.
Molten iron rain. Dude, that would fuck up your umbrella pretty quick.
You can say that again. It's one of the most extreme and bizarre weather phenomena we've ever observed in the universe.
All right, you've officially outdone yourself.
Mm-hmm.
Diamond planets, iron rain.
Mm.
What else could possibly top that? What other cosmic oddities do you have up your sleeve?
Okay, how about this? Imagine a planet so dark that it absorbs almost all light that hits it, making it practically invisible.
Invisible.
We're talking about Jervy S2b, a gas giant that's blacker than coal.
A planet that's darker than the depths of space itself? That's creepy as hell.
It is.
What makes it so dark? Is it like wearing some kind of cosmic camouflage?
We're not entirely sure.
Okay.
But it's thought that the planet's atmosphere might contain chemicals that absorb light very efficiently. It reflects less than 1% of the light that hits it,
Serious.
making it one of the darkest objects we've ever discovered. It's like a cosmic black hole sucking in all the light around it. If you were standing on that planet, it would be like being trapped in eternal darkness. Talk about a downer.
Pretty much. It's a stark reminder that the universe is full of mysteries and wonders that we're only beginning to understand.
Speaking of mysteries, you mentioned earlier that some exoplanets might orbit black holes. Is
Yeah.
that even possible? I thought black holes just sucked everything in like a cosmic vacuum cleaner from hell.
Black holes, DO, have an incredibly strong gravitational pull,
Right.
but it's possible for objects to orbit them without getting sucked in. Just like planets orbit stars, planets could theoretically orbit black holes.
Okay, but wouldn't it be pitch black on a planet orbiting a black hole? How would life even exist there? To be like living in a perpetual blackout.
That's where things get really interesting. If the black hole is actively feeding, meaning it's pulling in gas and dust,
Okay.
the material swirling around it could actually emit a lot of light and radiation.
So instead of a sun, you'd have a swirling disk of superheated matter lighting up the planet.
That's wild. It's like a cosmic disco ball.
It's a mind-boggling concept, but it's theoretically possible.
Okay.
And some scientists believe that this environment,
It's crazy as it sounds.
as extreme as it sounds, could actually support life.
Life that thrives on radiation and cosmic chaos.
Yeah.
Man, the universe is full of surprises.
It is indeed.
And we're just beginning to explore the full range of possibilities.
That's right.
All right, so far we've got diamond planets, iron rain, doomed worlds, invisible planets, and planets orbiting black holes. What else can the universe throw at us?
How about a planet with 3 suns?
3 suns.
HD 131399A is a gas giant that orbits a triple star system.
Okay.
That means it has 3 suns in its sky.
3 suns. That's straight out of a science fiction novel. What would the seasons be like on a planet like that?
Chaotic, to
Look-
say the least.
Yeah.
The planet's orbit is complex,
Okay.
and the amount of sunlight it receives varies greatly depending on the positions of the 3 stars.
Okay.
It would experience constant shifts in day and night,
Right.
and the temperatures would fluctuate wildly.
Imagine having 3 sunsets every day, or 3 sunrises. That would be pretty awesome, although I imagine getting a decent tan would be a nightmare.
It would be a spectacular sight for sure,
Yeah.
but it would also make for a very challenging environment for life to evolve.
Okay, this is blowing my mind. 3 suns, diamond planets, iron rain. What's the takeaway from all this weirdness? Are we even sure our definition of a planet is correct at this point?
The takeaway is that our solar system is just a tiny, tiny speck in a vast and incredibly diverse universe.
Right.
There are worlds out there that are stranger and more wonderful than we could have ever imagined.
Yeah.
We've barely scratched the surface.
It makes you realize how much we still don't know and how much there is left to explore.
Exactly. The study of exoplanets is one of the most exciting and rapidly evolving fields in astronomy.
It really is.
Every new discovery opens up a whole new world of possibilities.
Well said. I don't know about you, but I'm ready for more. Okay.
What other cosmic oddities do you have in store for us?
Hmm.
Lay it on me.
All right, let's talk about hot Neptunes.
Hot Neptune.
These are planets that are similar in size and mass to Neptune,
Okay.
but they orbit much closer to their stars. Imagine a souped-up version of our own icy giant.
So like a beefed-up Neptune. Neptune on steroids.
You could say that? Hot Neptunes are fascinating because they challenge our understanding of planetary formation. We didn't think gas giants could exist so close to their stars, but there they are.
Science is all about getting your assumptions kicked in the ass, right? It's like the universe is saying, oh, you think you know how things work? Think again, puny humans.
Exactly. Hot Neptunes are a prime example of that.
Yeah.
And they're a reminder that the universe is full of surprises.
Okay, so what makes these hot Neptunes so special?
Well,
Besides being hot, I mean...
besides being hot, for one thing, their atmospheres are incredibly dynamic and interesting.
Oh.
They're often shrouded in thick clouds of water vapor, methane, and other gases.
Imagine the storms on a planet like that. It would make Jupiter's great red spot look like a gentle breeze.
It's possible. We've observed some hot Neptunes with incredibly violent storms,
Yeah.
with winds reaching thousands of miles per hour.
That's terrifyingly awesome.
Mm-hmm.
So these hot Neptunes are basically like giant cosmic pressure cookers.
It's a good analogy. And these extreme conditions make hot Neptunes excellent laboratories for studying planetary atmospheres and the physics of extreme environments.
So we're learning a lot from these planets.
We are.
Even though they're incredibly different from anything in our own solar system.
Yeah.
They're like the rebellious teenagers of the cosmos,
Hmm.
breaking all the rules and showing us that there's more to the universe than we thought.
Absolutely. Exoplanets.
Even the weirdest ones.
Even the weirdest ones are helping us to understand the universe in new and exciting ways.
Right.
They're challenging our assumptions and forcing us to expand our horizons.
Well, folks, we've journeyed through a cosmic menagerie of strange and wonderful exoplanets in part 2 of our deep dive.
Yeah.
From diamond planets to iron rain.
We've seen a lot.
From doomed worlds to planets with 3 suns, we've seen that the universe is full of surprises. But hold on to your hats, folks, because we're not done yet.
Welcome back, Space Cadets, to the final frontier of our exoplanet expedition. We've seen some seriously wild shit out there.
Diamond planets.
Diamond planets.
Iron ring.
Planets darker than my ex's heart.
But now...
Now it's time to tackle the big one.
The big one.
Are we alone? Is there other life out there?
In the vastness of space.
In the vastness of space?
You've seen some crazy shit in this deep dive. Diamond planets.
Iron rain.
Planets so dark they make a black hole look like a goddamn glow stick.
But now we're getting to the real juicy stuff.
The question that's been bugging humanity since we first looked up at the stars.
Are we alone in this goddamn universe? Or is there some other freaky-ass life form out there?
Maybe sipping cosmic cocktails on a planet with 3 suns.
It's the question that keeps us all staring up at the night sky, right?
For good reason.
And for good reason. Just think about the sheer scale of the universe.
Billions upon billions of stars.
Billions upon billions of stars, each potentially with its own collection of planets.
And we're finding new ones all the time. It's like the universe is just spitting out planets, like a cosmic Tez dispenser.
Exactly. The more we look, the more we realize planets are probably as common as Starbucks on Earth.
It's getting harder and harder to believe that our little blue marble is the only place where life decided to throw a party.
I agree.
So you're saying the odds of finding some kind of alien life, even if it's just some microscopic space slime, are pretty damn good.
The math certainly seems to suggest that. Even if the chances of life popping up on any one planet are ridiculously small, the sheer number of planets out there makes it statistically likely that we're not the only ones on this cosmic dance floor.
Okay, so let's say you're right. How do we find these alien bastards?
How do we find them?
Do we just keep scanning the skies with our fancy telescopes, hoping to catch a glimpse of their spaceship zipping by?
It's a bit more complicated than that.
Nah.
Finding extraterrestrial life is like trying to find a specific grain of sand on all the beaches on Earth.
That's a lot of sand.
It's a monumental challenge. We're talking about looking for evidence of life on planets that are mind-bogglingly far away.
So we need to get creative. What are the tricks of the trade when it comes to this alien hunting business?
One of the most promising approaches is to analyze the atmospheres of these exoplanets.
Their atmospheres.
By looking at the light that passes through a planet's atmosphere, we can figure out what kind of gases are present.
Okay.
And some of those gases might hint at the presence of life.
So we're basically sniffing out alien farts.
Well, in a way, yes. Certain gases like oxygen, methane, and ozone are often byproducts of biological processes. If we find those gases hanging out in an exoplanet's atmosphere, it could be a sign that something's alive down there.
Okay, so we're looking for these so-called biosignatures.
Right.
But what if these alien dudes are breathing some freaky space gas that we don't even know about? Like, what if they're getting high off sulfur dioxide or something?
That's always a possibility.
Okay.
We have to be open to the idea that alien life might be completely different from what we're used to.
Yeah.
They might have evolved under completely different conditions.
Right.
With different chemistry, different metabolisms, who knows?
Like those silicon-based life forms they're always talking about in sci-fi movies.
Yeah.
Living rocks, basically.
Exactly. We can't limit our thinking to what we know.
Right.
We have to think outside the box, maybe even outside the goddamn galaxy, when it comes to searching for extraterrestrial life.
All right. So besides sniffing out alien farts, what other ways are we looking for ET?
Another approach is to search for what we call technosignatures.
Technosignatures.
These are signs of technology created by an advanced alien civilization.
Like giant space lasers,
Like what?
Death Stars, and warp drives. I'm all for that.
Well, maybe not that dramatic, but technosignatures could include things like radio signals, weird patterns of light, or evidence of massive engineering projects on a planetary scale. Things that couldn't be explained by natural processes.
So if we pick up a radio message that's all like, "Take me to your leader," in some alien language,
Yeah.
that's a pretty good sign we've got company.
That would definitely be a game changer. But we have to be cautious.
Okay.
There could be natural phenomena that mimic technosignatures, so we need to be sure we're not jumping the gun.
So it's a long shot, but we're still keeping our fingers crossed and our telescopes pointed at the sky.
Absolutely. The search for extraterrestrial life is one of the most important and exciting things we're doing as a species. Even if we don't find definitive proof in our lifetime, the journey itself is incredibly valuable.
It's all about pushing the boundaries of what we know.
Exactly.
And maybe, just maybe, getting a glimpse of something truly mind-blowing.
Couldn't have said it better myself. And who knows what amazing discoveries await us in the future? Maybe we'll find evidence of alien civilizations, or maybe we'll discover something even weirder and more unexpected. That's the beauty of science. It's full of surprises.
Well, folks, that wraps up our three-part epic on exoplanets. We started with those Wikipedia articles thinking, how much could there really be to say about planets outside our solar system? But holy shit, were we wrong. We've gone from diamond planets to iron rain, from rogue planets wandering the galaxy to the possibility of life lurking in subsurface oceans or huddled around a black hole. It's enough to make your head spin.
The universe is a vast and mysterious place full of wonders that we're only beginning to understand. And the more we learn about exoplanets, the more we realize how much we still don't know. It's humbling, exciting, and a little bit terrifying all at the same time.
So to all you listeners out there, keep looking up, keep asking questions, and never lose your sense of wonder. The universe is out there waiting to be explored. And who knows, maybe one day we'll finally answer that age-old question, are we alone? But hey, even if we are, at least we've got each other and a shit ton of awesome planets to discover. So until next time, Space Cowboys, keep it cosmic.